video for the University of Lethbridge Department of Mathematics and Computer Science 2610 by Nicole Wilson. In this video we'll be doing question 1b of the lab exercise 0, the sample lab. As you may or may not recall, depending on what you've looked at, in question 1 we were asked to consider the Boolean expression x and y, or not x and not y. We've already made a truth table for it. Now we're going to draw a logic diagram for this Boolean expression. And we're going to put our answer here in the same answer file that we already have this lovely truth table. So this is a logic circuit, and we use some software called LogiSim. This is free software that's available for PCs or Macs or the Linux box, so it doesn't matter where you are, you can get a hold of this. So when you start up LogiSim, it looks like this. I recommend you go through and get all of your gates first and then connect all the wires. So in this case, remember that we need an input, so that's over here. We can add a pin, input. So click and then click where you want it, 2 inputs. Then we need a NAND gate, so under gates here we have a NAND gate. I'm going to put that up here. We also need an AND gate and 2 inverters. We're going to take those two and we're going to OR them together. And then we need our output up here. So now everything's available, and we're going to hook things up. Make sure you've got everything where you want it. It's more difficult to move things around once we've got them hooked up. So notice there's 5 spots on these big gates to hook things up. Although this isn't true with actual circuits, with these, if you don't have some of them hooked up, they're ignored. So I'm going to use the top one for that switch and the bottom one for this switch on the NAND gate. Similarly, my knots are going to line up top and bottom on the AND gate. So I can hook this directly up on this one. I want to take this one, so I'm going to go over left and then up to where I want to hook it up. Notice we get a solder point there. Over to left and then up here. And then this is going to hook to the top, and this is going to hook to the bottom. I'm going to hook this one up, I'm going to go down, and notice if I can get one bend in there, but not too easily. So I'm going to put that one bend in, let go, and then connect from where I made that. So you have some control over how this looks. Oh, I went a little far. Control Z undoes it. And then I'm going to hook the output up. And as soon as I hook the output out, it changed to a 1. If any of these wires are not dark or light green, it means things aren't hooked up properly, or other signs if you can't see the colors. If you don't have a 1 or a 0 being output here, once you've got it all hooked up, something's gone wrong. If you get all kinds of weird stuff happening and you can't figure out what's wrong, worst case scenario, it just goes crazy. Just get out of the program, shut it down, start it up again. That usually takes care of it. So here's everything. Now we want to put in some titles. So we want to label it. So I'm going to pick this labeling tool here, and I pop that down. I'm going to say this is my X, this is my Y, and my output here, remember, is X and Y, or not X and Y not Y. These are not where I want them to end up, so I'm going to use this tool, the pointer again, to grab them and move them around. Perhaps looking at them, there's something I want to change. I've got it sans serif plain 12 right now. big enough. I want to go up to 18. I can change it there. And now it's a little more legible. Okay, so the reason we make these logic circuits is not just to have a nice picture of things, but to test to make sure the way we think the circuiting is going to work will in fact work. So we're going to take this and our truth table here. Oops. Go. And we want to make sure that we get the outputs we expect when we test this. So we take the hand over here. Right now our two inputs are 0, output is 1. 0, 0 gives us a 1. Good. 0, 1. Click on it to change it. 0, 1 gives us a 1. 1, 0 gives us a 1. And 1, 1 gives us a 0. Good. So this works. Now I want to put it in here. If you are on the Linux side, there's a K-Color snapshot program that does the same thing as Snip does on a PC, and I don't remember how to do it on a Mac, but if you have a Mac, I bet you know. So we choose New to get a new snip and just drag around it. And there it is. It automatically copies, but you can do Control-C if you want to be sure. Just click in here where we want it and paste. And there we've made the logic circuit for this question.